Hey everyone, welcome back, and today let's solve LeetCode problem 1910 titled Remove All Occurrences of a Substring. So we're given two strings s and part, and we want to perform the following operation on the entire input string s until all of the occurrences of the substring part are removed. So first we have to find the leftmost occurrence of the substring part and then remove it from the input string s. And effectively, once we're done applying that operations until we remove all the occurrences of that input substring part, we want to then return the input string s. And a substring is defined to be a contiguous sequence of characters in a string. Contiguous really meaning adjacent or consecutive. So in example 1, we have our input array, or rather our input string s, to be the following, and our part is ABC. Now what this part ABC really signifies, effectively it's telling us that we want to remove all the occurrences of ABC, that specific substring that appear in our input string s. And in this case, after we actually remove all of the occurrences of ABC, we actually get an output of DAB. And to kind of simulate this and walk through how those operations would kind of play out in this example, first we'd have the D, then we'd have the A, then we have the another A, then we have the B, but then we have the C. Notice how once we get the C, we know that our previous two characters were B and A in that specific order, right? So that really tells us that since our previous characters in formal order were A and B, and now we're adding a C, we know that we've actually formed our part. And so instead, we can just remove the A, B, and C from our current resulting list or string. Okay, once we actually get that, let's move on. We see this B, we see this A, we see another A, we see this B, and then we see this C again. Now we see that, okay, we've adding our C, but we also see that the past two characters are AB. Now we have ABC as the last three characters of our current resulting list, and so we want to remove those three characters because they are actually equal to the substring part. Okay, great. Once we've removed that, we simply go to the B, then the C. We've processed all the elements, and we return whatever our output string is. And it kind of simulates these operations here as well in the explanation. Right, we remove this ABC, we remove this ABC, and we remove this ABC. I may not have shown the third operation for the ABC. I may have missed that, but I hope you guys get the idea. Right, and now once we actually our output string s should have exactly 0 occurrences of ABC, because that's of course what the entire use case of the operation really is. So in example 2, we have our input string s to be A, and then 4 x's and 4 y's, and then a b, and our part in this case is xy. And in this case, we can actually remove this entire middle portion of the 4 x's and 4 y's to simply just get this ab, because of course the ab doesn't have any occurrences of xy. And the way we can do this is actually say, okay, we get a, then we get x, then we get x, then we get x, and then we get this another x, and then we get a y. Once we get this y, we see that our last two characters are xy in the current resulting list or string, and so we can remove these xy. Then we get to another y, we see this x and this y, this is also there, so we can remove those two top characters. Then we get to this third y, we see that this inner or nested x is also matching with this third y as the current top two characters, so we remove them, and effectively we, in that same logic or fashion, remove all 4 of these x's and y's, or all 4 xy's from the input string s, and we get ab as our resulting string. So for the constraints here, we see that the length of our input string s and the length of our input substring part are both never going to exceed 1,000, which in runtime complexity isn't too large in any way or form. And we're also given that the input substrings s and part always are guaranteed to consist of lowercase English letters. Just a really good quick thing to know, because we are guaranteed that we always will have valid inputs. So with the problem statement, constraints, and examples out of the way, I will give you guys a few seconds. You're going to just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so the nature of this problem really just signifies very clearly, at least in my opinion, after extensive amount of experience with these data structure, that this really is just a simple, straightforward simulation stack problem, right? And I think my walkthrough hopefully kind of help you guys figure out that this is really just a straightforward stack problem. Effectively, we continuously or iteratively add the elements from our input string s to the stack, but once we actually find the top n characters in our stack to be equal to the part, where n is the length of our input string part, we know we have to remove them because, of course, we've actually found part, and we want to remove the characters that actually form that occurrence of part from our original input string s, and accordingly add them to our resulting list, or our resulting string, right? And to kind of quickly formalize the high-level rundown, how we're actually going to solve it. Basically, we first iterate through each character in the input string S. We simply append it to the resulting stack. And after we actually append each character, we then have to check, okay, are the last couple characters, like I said, the last n characters in that current result stack, do they actually equal the part? If they do, we've actually found one more occurrence of the current substring part, and so we can remove the last characters, n characters, where n is the length of the part, from the result. And at the end, once we actually remove all of these occurrences of part, we simply join the list into a final string and then return it, right? So very straightforward solution. Now, what you guys may have thought if you haven't actually used the stack is basically just keep searching for part in S and then simply just remove it repeatedly. But obviously that isn't the most efficient solution to do this. I know it wouldn't be as memory efficient or take as much memory because we wouldn't be using an extra memory for stack, but it would still be an inefficient approach because of course we have to actually build that final string dynamically, or rather we have to actually get all of those substrings apart in it very slowly and efficiently. That would be very time consuming, right? And instead, again, kind of tying back to our current most efficient solution, we have to actually use a stack because of course we can actually build that final string dynamically in each iteration to actually get all of the valid characters as such per se from our input string S that do not contribute or form any occurrences of our substring part in that entire input string S. So with that kind of high-level rundown of our solution out of the way, let's go ahead and dive into the code here. So what I'm first going to do, like I just talked about, I'm actually going to initialize my resulting stack. I'm going to call it result stack like I did in yesterday's problem as well. Feel free to just call it stack. It doesn't really matter what you call it. And now let's actually iterate through each character in the input string S and check if it actually does contribute or form a substring or an occurrence of the substring part. So basically for every single character or char in our input string S, we first want to add it to our result. So result.append S as a potential valid character. But what if now, after we actually add the substring S in this iteration, what if the current stack's topmost n characters, where n is the length of our input string part, what if that actually equals a part? That means we've actually just formed our an occurrence of our substring part, and so we have to actually delete it or remove it from our resulting list or our resulting string. And the way we can check that in Python very easily, or at least relatively simply, is we can actually use a string.join method. So if the string.join of the result, I'm going to be using something called list slicing here, I'll explain it in a second, of the negative length of the part up until the end of the part, if that's actually equal, and sorry, I think this should be here, if that's actually equal to the part itself, we know we have to actually remove or delete these top characters or this top occurrence of the substring part from our resulting list. And so we can actually use a del keyword in Python and simply say delete or del the result, you guessed it, at negative length of part, because those are the last indices, last n values from the last n indices of the input string S if they do actually form or contribute to an occurrence of the substring part. And effectively, once we do this, we simply return the resulting result stack, but of course we want it in terms of a string rather than a list, and so we have to actually combine or join all the characters in this input into a single list into a single string using the string.join method in Python. Right now, let me just actually quickly get the resulting stack rather than just the result. Give me a minute, guys. And I think now there should actually be an accepted solution. Let's go ahead and double check that real quick. Okay, let's see what I did wrong here. Probably just a little quick syntax error on my, okay, so this should be a, or char. Sorry about that, guys. I accidentally appended the entire input string S in each iteration. Shouldn't be doing that. But now, as you can see, this really is just about as efficient as you can get it to be. Now, I didn't really explain in depth the way these two kind of lines of code actually worked out. And so let me actually kind of go back to how that really works out. Effectively, for every single character or char in the input string S, we first add it as a valid potential result to our result, right? Now, here we're simply checking, okay, are the last or top most n characters, the most recent n characters that we've added to our stack, do they actually form an occurrence of the substring part? Now, the way we can actually get n to be the length of the part is in a very kind of quick way here. Basically, we're checking if the last length of part characters in the result actually form that substring part, right? And the kind of tricky way to, or rather a simple kind of way to do this in Python is negative length of part. And what this colon here in the indice is actually saying, it's basically something called list slicing, where we're going from the negative length part indice up until the end of the array, basically kind of stimulating the topmost n characters or the topmost length part characters. We're kind of extracting the last few elements equal to the length of the part and checking if it is actually equal to the part itself. And if it is, we've found an occurrence of the substring part in the input stack, or rather in the list stack, and so we have to actually remove it. And a very simple way to remove it is simply use the del key, where we delete the last length of part elements from the result, basically removing part from our string, this current occurrence of part from our string. Those current or most recent topmost n characters, if they actually do form an occurrence or equal the part. Right? And why we're using string.join is because, of course, the part, of course, by itself is actually an input string. And when we actually list slice, of course, it's in the name, we turn all those characters and join them into a list. We want to actually compare a string with a string and not a list with a string. And so we have to actually join that topmost characters into a string rather than keeping them as a list, because of course we want to convert the list slice into a string to compare it efficiently with a string, because we can't compare lists with string and expect to get different results regardless of if they're equal or not. And here, if we basically find a match, we delete that current occurrence or length of part elements from the result, basically simulating removing the part from our string. And effectively on line 8, we're simply joining the list back into a string and just returning that result. So to kind of reiterate on a very, very high level rundown how the solution actually works, we kind of just talked about this in the previous parts of this video as well. Basically, the main idea is we're actually using the stack to actually dynamically build that final result while also checking for occurrences of part in each iteration as we actually append elements to the result. Basically, we iterate through the input string s, we add characters to the result, and whenever the part forms at the end, basically if the topmost n characters or n is the length of the part, if that actually does form as the part from our resulting list, we then have to remove it. And since we actually process s in a single left to right pass, this is actually a very efficient solution, right? So getting to our run and spacetime complexity, for the runtime complexity of this solution, it's actually going to be a big O of n times m, technically, right? N would be the length of our input string s, and m would be the length of part. Why? Because of course, each character that we actually kind of process, we actually do add it once and remove it at most once from our resulting string stack. And of course, in the worst case, every single m character that we remove would actually require us to check the last m characters, and that would actually technically lead to a technical time complexity of big O of n times m. But really, in most cases and in really practical inputs, our runtime complexity is going to be simplified to be much closer to big O of n or a linear time solution. And so the memory or space complexity is actually also going to be big O of n or a linear time solution, and would simply be the length of our input string s. Why? Because we're really only using one extra data structure here in terms of auxiliary memory, and that is of course this resulting stack. And of course that would be to store the modified string, and in the worst case that could store all of the characters in our input string s, in the case that we don't find any occurrences of part, meaning we don't delete any characters that contribute to the part in our input string s. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.